Our door insulators are an important part in overhead lines. They are responsible to do two main jobs. The first one is to mechanically hold the conductors and electrically to insulate it from the tower. And there are, as we know, two main types of overhead lines. There is transmission lines and there is distribution overhead lines. Now, the configuration of the insulators while doing these two jobs comes in different shapes. So here, for example, this is the most common type of outdoor insulator configuration, which is the suspension type of outdoor insulators. Suspension type, basically what they have the conductor coming from the bottom part, where is the energized part of the insulators, and the top part of the insulators is connected to the tower, and the mechanical load applied to the insulator here is tension type. The second common type in outdoor insulators is the dead end, and you can see here the insulators are in a horizontal position, unlike the suspension type where they are in a vertical position. This type of insulators is used in a dead end where the line is terminated. As you can see here, the line is ending here and terminated here, so we call this is dead end configuration. Now this one also, this type of insulators is subjected to a tension type of mechanical force. Now we will go and see in overhead distribution lines what are the most common types used there. The most common type of insulator configuration in distribution lines is the post insulator. And in the post insulators, the high voltage lines come from the top of the insulator, and the bottom part of the insulator is attached to the pod. So this will make the mechanical load on the insulator is a cantilever type. The second common type of insulators in distribution lines is again post insulators, but on a cross arm, as you can see here, and also the insulators are connected from the top by the high voltage line, and the bottom part is connected to the tower. Another type of distribution insulators is the dead end. Dead end means the line ends here, there is no continuation of the line. So in dead end configuration, as in transmission lines, the insulators are in a horizontal position, and the mechanical load applied to it is a tension type, not a cantilever type like the post insulator. The question is, what is the difference in the mechanical design of the insulator if it has a cantilever force or if it has a tension force? Let's go to the lab and have a closer look to these insulators. In this video, we would like to see what is the difference from the mechanical design perspective of tension, suspension, dead end insulators, or post insulators. So here, these are two examples of dead end and suspension insulators where they will have a tension type of force. So have a look to the core size. See the core, it is small. Now when you look to the post insulators, these are some examples of post insulators, and you look to the core here. So the core compared to the suspension or dead insulators, it is much larger. And why is that? Because of the nature of the mechanical force. In post insulators, we have the mechanical force as cantilever, which is more severe on the integrity of the insulators. On the other hand, for suspension or dead end insulators, the type of the force is tension, which is much less severe than the cantilever force, and this is why the core design is much smaller than the core design of the post insulators.